That
Yeah.
you just make it a rectangle instead of using the radius in the new rec, and that takes care of everything.
Yeah.
So
So I'm going to move on to step 2. We're going to look at a triangle now. Okay, so here's the
I just
problem
want
we
to.
had in...
Oh, sorry. So just the pro tip there then is if you're having problems, turn on hybrid mode, right?
Oh,
Yes.
absolutely. Yeah.
It'll all become
Yes.
obvious.
Always investigate a little more. And one of the things you can do is simply turn on hybrid mode, which is, if people don't know what we're talking about here, is, where is it? Talk, physics, set draw mode, hybrid. Make that a little bigger so you can see it. This bit right here. After you start physics, set hybrid mode, and you'll be able to see the collision boxes. I've already turned it off, but it was that green bit, and it will also show you a little... let's just turn it on. It'll also show you these, probably really hard to see, a little line here and a little line here, which tells you the orientation of the body. So positive X, positive Y, going down.
Cool.
So if you've rotated your group, that's when you'll say, oh, if these are ever not at a 90-degree angle to the screen like this, then you've rotated your group. It's not the body, I don't believe. I could be wrong. Now I have to investigate, darn it. Okay, pretend I didn't open my mouth there. Okay, so this is where we were. Our mind is telling us the ball's going to hit here, and it's going to follow this track. But then again, we do this, and you notice here I'm leaving a little trail behind. You can see exactly where it went. That is what happens. So why is this happening? If you run step 3 in the talk, it'll put up a couple of dots here. So what's occurring is this thing is moving along, and let me see if I can stop it when it's doing it. Okay, there it is. So it's had the collision, and the collision doesn't happen here like we're expecting it to. It happens here. So our mind says it's going to be here, but it really occurs here. And as soon as it hits here, what happens? This is a 45-degree angle. It's going to change the direction of this from this. It's going to change it by 90 degrees, basically, if it's coming in.
Horizontal.
Is that correct?
It's going to go from horizontal to vertical.
Yeah, basically it's going to go from a horizontal motion to a vertical motion, as we can see. So how do we fix this? The way we fix it is we change the point of impact. What we want is we want the body to move through this line, and we want it to change direction when the center of the body, the moving circle, is in the center of our track or our grid. So the only way to do this when using physics, via a collision, is to move the point of impact. So what we do, for in the talk code, I'm changing things here, right here. So talk run 4, and I should have said that at any time you want to render hybrid mode, you just set this to true, but I'm going to leave it off for the most part. So we're on step 4. So step 4 shows the square block, which is sort of our reference for how the grid would be laid out. The red one here is our original incorrect sized body. And this one here is actually the correctly sized body, which leads to another problem. But before we get there, let's just prove that this works. Come on. Da-da-da. Okay, good. So now what we've got is it follows the track exactly. We know that if we use this technique, no changes, we could build a grid, we could put our objects placed correctly, and everything would work. I mean, it would follow the orientation. However, having done this, we've produced for ourselves an issue. How do we calculate the placement of this shape? Additionally, it looks terrible. This block is about 1/3 of the size of this block. So I just want to stop at this point and say, for people who are making a game that is not like Ichi, if they want to make an Ichi-like game, our discussion continues. But at this point, you can stop. The thing that you need to take away is if you're trying to get this kind of motion, you need to consider the point of impact versus the angle here. And it's the discussion we just had. We had to move the point of impact further away so that the point where it changes direction is here. And this is the thing that people mess up all the time when they're thinking, okay, I'll just make an angled surface and it'll bounce, and then they're like, wait, it didn't bounce the way I expected. It's slightly offset. And the reason is the collision point was further down. It's over here. All you got to do is move it further away, keep it on track. So what about Ichi? Like I said, this piece is very small, and if we were to make our game like this, it would look kind of wrong, kind of ugly. Now, if we go back and look at their implementation, you'll notice that this block, although not exactly the same size as this block, is pretty close. It's like maybe 10% shorter. And they did this thing where they rounded the corners, and you can't see it in this static image, but I'll show it to you too, is that these pieces throb. They get smaller, they get bigger. They get smaller, they get bigger. And so all of this, slightly smaller, and the throbbing, the rounded corners, is combined to help trick your brain, and there's one more thing, to trick your brain into thinking, they're all the same size, or close enough.
Hey, Sergey, did you have something you wanted to throw on that?
Yeah, I want to share my thought, like what else could be done. As Ed pointed out, this is a physics problem, and one way to solve this is to not use physics. But if you want to use physics, you can actually combine physics and not physics methods together. You can use pre-collision event with a platform, like normally sized platform. And when that happens, you take control over the ball, over the object that collides, and you can translate it to the center of the figure, despite the actual boundaries, and then do another transition from the center. And when it leaves the object, you give it actual physics properties like speed and stuff.
So, oh my fire!
Oh, is that kind of where we're headed?
One thing on top of that, though. Everything Sergey said, but you'd want to make the body a sensor.
Yeah.
I've heard a lot of, or not a lot, but I've heard several discussions where people are saying, well, you don't need to use a physics engine for that.
Yeah.
So is there a benefit to one or the other, or is it just 6-1, half dozen?
If you have a strictly grid-based game, then using not physics would probably be better, because you would not end up with some weird behaviors of your objects.
I'd also want to say that Sergey's solution he did steal my fire, but I'm glad he brought it up.
So you have it.
I think I said it already at the beginning of the show, but this solution that I've presented and provided is not the best solution for making Ichi. The one that Sergey just mentioned is the correct final solution. It's to use a combination of physics and some other mode of aligning and changing direction. And the reason is, and to answer your question, Charles, is that physics is great when you want to have nice feedback and things that feel natural, and you don't care about 100% accurate precision all the time. The problem with physics is one little tiny mistake, like I was going to mention this, is in the sample code, when I make the big rectangle, I'm showing you, let me show you the screen here, I'm sorry, I'm pointing at it. When I make this big triangle, I use a feature of Corona called use outline. So instead of making the shape for the body, I just say, hey, look at the texture, and anything that's transparent, assume that that's going to be the outline of the body. So the body is the opaque part. The translucent part is the non-existent part of the body. But the problem is that creates an angle that is not exactly 45 degrees, and because of that, the collisions go wrong eventually. They get slightly perturbed. Another thing is timing errors and placement, alignment errors, and subpixel changes in the grid, and little details like that can all affect the physics calculation, which is based on floating point numbers, and it's got to be extremely precise to get this kind of response, which is come in at this angle and go off at exactly 90 degrees.